Hello, Form 3 students. The coming Wednesday will be our next online lesson. And before that lesson, you have to complete the following homework about inclination. Just talk about before the long holiday. So inclination on coordinate plane actually is a similar concept with the inclination in gradients. Okay, similar concept, but be careful. You have to identify the inclination of the straight line carefully. Okay, if we have the coordinate plane like this is x-axis and this is y-axis, and if we have any straight line like maybe this one, we call it L1 line on the coordinate plane, you can see that L1 cuts the x-axis here, and officially inclination refers to the angle. You start on the x-axis on the right hand side and then go anti-clockwise until you meet the L1. So this angle is the inclination of L1. Okay, this angle is the inclination of L1. So if I draw another one, maybe I use orange, draw L2 here, then this time L2 cuts x-axis at here, and the right hand side x-axis start with here and then go anti-clockwise until you go to L2. So this is the inclination of L2. So you can see that this time a bit different from gradients. The inclination of the straight line on coordinate plane can be less than 90 degrees or greater than 90 degrees. Okay, one more thing to remind you, actually sometimes you may meet the straight line. Let me draw another coordinate plane like this. Okay, maybe on the part you can see it doesn't intersect with x-axis. So how can we find out the inclination? How to find the inclination? Actually, you may draw any horizontal line that pass through L1. Horizontal line means parallel to x-axis, and then you can use the same method, means start on the right hand side here and then go anti-clockwise until you meet L3. Maybe I should name it as. So this is the inclination of L3. Actually, this is the inclination also, because if you extend L3 and let me extend the x-axis also, this angle is the inclination by definition, and these two angles must be the same by corresponding angle. Okay, so let me have a little summary here before we do exercise. For inclination, officially you should find out the point intersect with x-axis, and then you can see that the L1 cuts the x-axis into two parts. Start on the part on the right hand side, goes anti-clockwise until you meet the straight line. This angle is your inclination. Okay, it can be greater than or less than 90 degrees. Or in another way, to find it in a quicker way, if you need to find the inclination of any straight line, maybe I call it L4, you can create any horizontal line or make use of the x-axis, which is also a horizontal line. And then at the intersection, you can see that actually you have 1, 2, 3, 4 angles, right? 1, 2, 3, 4 angles. The angles on the right up corner. Mean this one on the right, these two on the right, 2, 3 on the right, and the upper part, right up corner, actually is the inclination. Okay. So this is how we define inclination on the straight line. This is the second thing. This is the first thing, how we define inclination. And second thing, why do we need to learn inclination? Because inclination actually is related to the slope. Before the holiday, you learned that the slope of a straight line, if we have 2 points called x1, y1 and x2, y2, and then the slope of AB, can be calculated by the difference of their y coordinates divided by the difference of their x coordinates in order. Or actually, it can also be defined as tangent theta. Okay, it can also be defined as tangent theta. This is something relates to, you can draw a right angle triangle here, but actually you can't deal with the case when the inclination is greater than 90 degrees, because this is behind the scope of junior form. You may learn it in form 4, but never mind, I think you can treat it as a formula. Actually, we can have two ways to calculate slope. Slope can be calculated by this one, the original formula you learned before, or calculated by tangent theta, okay? By making use of this two, you have to do the following exercise. So let me do some example first. This one, you know that the slope is 1/2. Find the inclination. Okay, how can we relate slope and inclination? You know that slope actually equals to tangent theta. Okay, slope is equals to tangent theta. So to start your question, you may let theta be the inclination first, because we need the symbol of L1. So slope is 1/2 equals to tangent of theta. So by your calculator, you have to input tangent -1 1/2 into your calculator. Okay, into your calculator, this one. You may find that the answer is this one. Correct to 3 significant figures if it is not stated. Oh, no, sorry. It's stated near 0.1 degree, so 26.6. And then for part B, if the slope is twice mean 2 times of L1 is the inclination of L2, also twice of that of L1. So the slope of L2 is twice of L1, which is 1. And then we have to find out the inclination of L2. Let theta 2. The little 2 here, we can indicate that this is the slope of L2 matched with the little 2 here. So actually, if you want, you may let the theta in part A as L1, that you can match the little 1 with the L1 and little 1 here. So you have to add, I suggest you can add one more sentence that for the inclination is 26.6 degree. Okay, and then come back here, part B, let theta 2 be the inclination of L2. And then once again, the slope, which is 1, equals to tangent of the inclination L2. So theta 2 by your calculator, this is 45 degree, which is not equals to theta 1, because you can see that the twice of 26.6 should be 53.2 something, which is not equals to 45 degree. Therefore, the answer is no. Okay, the answer is no. Okay, the next question, find out the inclination of L. So this time you have to identify the position of L clearly first. So now L intersect x-axis here. So you have 1, 2, 3, 4 corners. The upright corner will be the inclination. So where is the upright corner? Yes, number 2 angle. This is the inclination. Okay, this is the inclination. Let me cross out the others. So this is the inclination. After you find out the correct position of inclination, you can tell me the answer for part A, because this is easy to calculate, so I don't let theta. Inclination of L equals to 180 minus 145. So this is 35 degree. So part B, the slope of L. Once again, slope of L. Slope can be calculated by tangent theta, so equals to, we know that theta is 45, tangent theta. So by your calculator, the answer should be 0.700. Oh, 2 decimal place only, so 0.70. Not difficult, right? So let's see one level 2 question. This time, you have R, this one, with inclination, this one. L cuts the x-axis as P and Q respectively. But this time, it tells you many information about the graph, but it doesn't give you the graph. So I strongly suggest you to draw the graph yourself. Sketch it. Means roughly draw the position, the relative position of all the things. So you may first draw the axis, and then 7, 2. So let me use 2, 4, 6. So about here is 7. Go up for 2 units. So 7, 2 should be somewhere here. A rough position of R. And then with inclination 45 degree means you have to draw L that pass through this point R and mix 45 degree with X. Okay, so the position of L should be something like this. Okay, mix an angle 45 degree with X. So this is L, and then L cuts the x-axis and y-axis at P and Q. So this one is P. We have to extend it and cut the y-axis. So this one is Q. Okay, P and Q. So find out the coordinates of P and Q. So what can we do? First of all, for the coordinates of P, as P lies on x-axis, we know that the y coordinates of it must be 0. So we can let the position of P be P0, little p0. And then similarly, Q lies on y-axis, so the x coordinates must be 0. Q can be 0, Q. So the first one, I will let P be P0 and Q be 0, Q. Okay, for easy calculation, give some symbol first, and then calculate P and Q separately. You have the inclination, so in your mind you know that, okay, actually if you give me the inclination, I can find out the slope. And now R, P and Q are collinear, they fall on the same straight line L, means the slope of PR actually can equals to the slope of RQ equals to that one you find here by inclination. So this is our idea. How can we find out the value of P and Q? So let me calculate the little p first. Slope of PR, okay. Slope of PR can be calculated by 2 minus 0 and then 7 minus little p. Remember, y difference minus x difference, okay, equals to the inclination. The slope is tangent of inclination here, means 1. So 7 minus p, tangent 45 is 1. I hope you can remember this. So p is 5. And then similarly, slope of RQ equals to 2 minus q, 7 minus 0, as they fall on the same straight line, so same slope, still tangent 45 degree. So you have this one, the value of q is minus 5, negative 5. Therefore, once again, the coordinates of P and Q are, okay, no problem. The coordinates of P should be 5, 0, and the coordinates of Q should be 0, negative 5. Okay, so I think this is the 3 examples of inclination. Try to finish the following homework given. Bye.